A while ago I was looking at the Godot's documentation, and there was a part that caught my eye. So let's revisit it. The page is called Performance, and if we scroll down a bit, there's a link to a tutorial called Optimization Using Servers. Here it talks about servers, a low-level construct that can reduce the load on some systems. But the interesting part is here. It says, one of the most interesting design decisions for Godot is the fact that the whole scene system is optional. And while it is not possible to compile it out, it can be completely bypassed. That got me wondering, if we can completely bypass this scene system, it means we can create a game that doesn't use any nodes, which are a fundamental part of Godot.
Is that a challenge?
The Godot's documentation doesn't elaborate on that, so I'll try to explain from what I understood. When we want to extend the functionality of some existing node, or literally anything, we add a script. And this is pretty much similar to inheritance. In fact, this is what the Godot's architecture all about. The root of it all is an object, so a node also inherits from it. It is essentially the least common denominator in the realm of Godot, unless it's a primitive type. The scene tree, which controls the nodes, also inherits from the object. But contrary to what I thought, it doesn't directly do that. Instead, there's a middleman. And it is called main loop. Main loop controls stuff like program execution, its initialization and finalization. So this is what makes our program work. And we can inherit from it ourselves and create our own custom main loop that doesn't depend on nodes. This will be the starting point of our nodeless programming in Godot, as we will not need any of this. Talk is cheap, let's start coding. In an empty project folder, we'll need to create a file called project.godot. And here we'll need to write config version equals 5, application, run, main scene. This will be the main scene, but since we don't have any, I'll just write space. You need something in here. And the most important part is main loop type. And here we'll need to give it a name of our custom main loop. In our case, Godot main. Okay. And if I run it, you see that it works. Okay, here it says resource file not found. It means that it worked. The next thing is to add our main loop. So we'll need to write extends main loop and give it a name, class name, that is identical to the one we wrote here. Okay. Now, it has few functions that it provides: initialize, and here I'll pass for now. Process, I'll do this, and here I'll return true. And finalize, also pass. Okay, so let's check this one. So yeah, it started and then it ended. Now, where do we move on from here? The first part is, let me actually change this one to false. You'll see immediately there are a few problems. So yeah, it launched, but there is nothing. It's just a splash screen. What we need to do is create a viewport. It doesn't have a viewport that is included in the scene tree. So I'll create a variable. Actually, I'll create a variable in the global scope called viewport. It will be an RID. And here we'll initialize it by using the rendering server. viewport. What did I just write? Viewport create. Here we go. The next part of initializing our viewport, like, yeah, we created it, but now we need to initialize it. We need to make it active. Viewport set active, viewport, and true. If we don't do that, the viewport is inactive and we can't use it. Next, we'll need to attach it to our screen, to our window. We can do this with the function viewport attach, viewport soon, attach to screen, viewport, and we need a rectangle. So let's obtain the rectangle that was provided by the window. Window rect, it will be a rect to I. And here we'll initialize it. Equals to I. The first part will be a vector to 0. The second part is the one obtained from the display server. Window size, get size, yeah. And here we go. We can now attach it to the screen. Let's see, now it should turn gray. It doesn't. That's because I forgot to set its size. Size. Okay. Now it should work. Here we go. But you will notice that we also have a cursor that is like really strange. Let me actually make my cursor a bit bigger. Here, the cursor is being weird. So we'll need to set it properly. Display server, set, cursor, set cursor. Set shape, actually. Set shape, display server, cursor shape, arrow. And here we go. Now, you'll notice that we can't really close the window. We need to provide a few callbacks to the display server. Let me first create a function that will respond to window events. Display server window event. And let's match the event. It will be window event. The how is it called? Close request, yeah. And here I'll need a variable again. Boom, equals false. So we have to return false if our process is running, and true if we want to close the process. So that's precisely what we'll do. False, true. And also here I forgot to finalize our viewport. So let's do that. Rendering server, pre-RID. We have to do this with every RID that we obtain from the servers. They do not have automatic memory management. Oh, what happened? Oh, I forgot. We need to add the callback. Display server, set window. Yeah, Windows set window event callback. And here we need to add the callable, which is window events callback. Here we go. Now we can close it. Let's go. There's also another thing. If we try to resize our window, you'll see that the viewport doesn't change. So we have this black emptiness at the sides. We can easily fix this by updating the window rectangle that we have. For this, we'll need to use the display server window set rect changed callback. And here we'll need to create another function. And window rect change. Actually, no, window size equals change size. We don't want to set the position. And finally, we'll need to repeat this one. We'll need to repeat the attach to screen and maybe resize, but yeah, I think resize should also be here. In the future, we'll be creating our own stretch modes. So yeah, that is to be fixed. It's temporary. Let's mark it as so to do. Okay. The next part is to actually attach the callback. So window resize callback. Let's check this one out. And yeah, it works. Not the best way, but it works. The next logical step would be creating the canvas and attaching the canvas to a viewport and then drawing to it. But I want to stop right here. What we essentially have is a functioning program, similar to the empty scene in Godot. Lastly, just for fun, I want to watch what happens if we go to the editor. So let's go to the editor and look at what happened to our game. You'll see here that there is literally nothing, even though we just ran it. Let's create a scene. I'll delete it later. We'll not be using Godot scenes. So yeah. And yeah, here it is. What we essentially have. Let's go to the debugger and let's look at the monitors. If we scroll down here, we'll see that there are no nodes, absolutely empty. And if we go to remote, it's empty. You can also see some errors here, but that is just in the editor. It doesn't affect the game. So yeah, that's pretty much it. We now have a functioning program in Godot that doesn't use any nodes. I think this is a great experimental project because it shows that how mature the GDScript as a language is and how much of Godot's internal APIs are exposed to the user. Remember that we didn't use any modules, we didn't use any GD extensions, we simply used the script and whatever was provided. I hope you learned something new about Godot or about programming in general, and I hope you have a nice day.